Oracle Backup and Recovery Lesson 7. Introduction. Good morning, everyone. I'm Mr. Bell from Ctech, CaesarBrotherTech.com, and I'll be your guide through today's lesson on Oracle Backup and Recovery Strategies. This is one of the most critical aspects of database administration that you'll need to master. Before we begin, I want to emphasize something important. Backup and recovery procedures are not optional in a production environment. They are absolutely essential. Without proper backup strategies, you risk permanent data loss that could potentially shut down an entire business operation. Let's dive right in. Part 1. Introduction to Backup and Recovery in Oracle. Backup and recovery are the foundation of database reliability and security. Think of backups as your insurance policy against the unexpected. Without them, you're essentially operating without a safety net. Oracle provides robust tools for creating and managing backups, but there's a critical prerequisite. Your database must be properly configured for backups in the first place. The most important configuration is enabling archive log mode, which we'll discuss shortly. If you overlook these fundamental configurations, recovery from failures becomes extremely difficult or even impossible. I've seen database administrators learn this lesson the hard way, so let's make sure you're properly prepared. Part 2. Preparing the database for backups. 2.1. Enabling archive log mode. Let me explain why archive log mode is so critical. Oracle uses archived redo logs to track all changes made to your database. These logs capture every transaction and modification after your last backup. Without archive log mode enabled, you can only restore your database to the point of your last full backup. Everything after that would be permanently lost. This is what we call a point-in-time recovery limitation. Let me show you the exact steps to enable archive log mode. First, you'll need to shut down the database and start it in mount mode. The commands are SQL shutdown immediate, SQL startup mount, then enable archive logging with SQL alter database archivalog, open the database, SQL alter database open, and finally, verify that archive logging is enabled, SQL archive log list. Once you've enabled archive logging, Oracle will begin storing these archived redo logs in a designated location. These logs become your transaction history, capturing all changes so they can be replayed during recovery if needed. Remember this, without archive log mode, you cannot perform point-in-time recovery. Write that down. It's that important. 2.2. Setting up backup retention and archival. Now, let's talk about managing your backups over time. You don't want to keep every backup forever. That would quickly consume all your storage. Instead, you need to implement a retention policy. Oracle's Recovery Manager, ERMAN, allows you to configure retention policies based on either redundancy or time. For redundancy-based retention, you specify how many copies of backups to keep. RMAN configure retention policy to redundancy. 2. This tells Oracle to keep 2 copies of your backup. Once the third backup is created, the oldest one is automatically deleted. Alternatively, you can use a time-based retention policy. RMAN configure retention policy to recovery window of 7 days. With this approach, Oracle will keep all backups needed to recover the database to any point within the last 7 days. Backups older than that are automatically marked as obsolete. I recommend starting with a 7-day retention policy for most environments, but your specific requirements may vary depending on regulatory requirements and business needs. Your Part 3, Types of Backups in Oracle. Now that we've configured our database for backups, let's explore the different types of backups available in Oracle. 3. 1. Full backup. A full backup is exactly what it sounds like, a complete copy of your entire database, including all data files, control files, and archived redo logs. This creates a comprehensive snapshot of your database at a specific point in time. To perform a full backup using RMAN, the command is straightforward. RMAN backup database. Full backups are essential, especially when setting up your initial backup strategy or after major database changes. They provide the fastest recovery path since you don't need to apply multiple incremental backups. However, full backups consume significant storage space and take longer to complete. This is why we also use incremental backups, which I'll explain next. 3.2 Incremental backup. Incremental backups are designed to capture only the changes made since your previous backup. They come in 2 levels. Level 0, incremental backup is essentially equivalent to a full backup. It serves as the baseline for future incremental backups. Level 1 incremental backup only captures changes made since the last backup, whether that was a level 0 or another level 1 backup. To perform a level 1 incremental backup, RMAN Backup Incremental Level 1 Database. The primary advantage of incremental backups is efficiency. They're faster to create and require less storage space. This is particularly valuable for large databases where a full backup might take hours. 3.3. Differential Backup. A differential backup is a variant of the incremental backup that captures all changes since the last full backup, level 0. Unlike regular incremental backups, differential backups don't build on previous incremental backups. To create a differential backup, RMAN Backup Incremental Level 1 Differential Database. The advantage of differential backups is simplicity during recovery. You only need to restore your most recent full backup and then apply the most recent differential backup. With regular incremental backups, you might need to apply multiple incremental backups in sequence. Part 4. Recovery Scenarios. Now let's discuss what happens when things go wrong. Recovery scenarios can range from minor, like a corrupted data file, to catastrophic, complete database failure. 4.1 Restoring Control Files. The control file is critical. It contains metadata about the physical structure of your database. Without it, you can't open the database or perform recovery operations. If you lose a control file, you can restore it from backup. RMAN Restore Control File from path to control file.bkp. If you don't have a backup of the control file, you may need to recreate it manually using the create control file command, which requires specific parameters about your database structure. 4.2 Restoring Data Files. If you lose or corrupt a data file, you can restore it from backup and then apply any necessary archived redo logs to bring it up to date. RMAN Restore Data File, Path to Data File, RMAN Recover Data File, Path to Data File. The restore command retrieves the file from backup, while the recover command applies any necessary archived redo logs to bring the file up to date with the rest of the database. 4.3 Restoring the entire database. In a worst-case scenario where you need to restore the entire database, the process is similar. RMAN Restore Database, RMAN Recover Database. This will restore all data files from the most recent backups and apply archived redo logs to recover all transactions up to the most recent available log. Part 5. Best Practices for Backup and Recovery. Let me share some best practices I've learned through years of database administration. 1. Regular backups. Schedule full backups regularly, perhaps weekly, and incremental backups frequently, daily or hourly, depending on your transaction volume. 2. Backup verification. Always test your backups to ensure they can be restored successfully. A backup that can't be restored is worthless. I recommend quarterly recovery drills where you restore to a test environment. 3. Monitor archive logs. Keep an eye on your archived redo logs. Ensure they're being created correctly and that you have sufficient disk space. If the archive destination fills up, your database will freeze until space is available. 4. Retention policies. Implement appropriate retention policies to manage storage efficiently. Don't keep backups forever unless required by regulations. 5. Backup encryption. Consider encrypting your backups, especially if they contain sensitive data. This prevents unauthorized access if backup media is lost or stolen. Conclusion. Today we've covered the fundamentals of Oracle backup and recovery. Remember that your ability to recover from disasters depends entirely on the quality and availability of your backups. In my experience, database failures don't announce themselves in advance. They happen suddenly, often at the worst possible time. Your preparation today determines your success tomorrow. For next week, I want each of you to set up a test Oracle database, enable archive log mode, and create a backup strategy including full and incremental backups. We'll review your work and perhaps even simulate some recovery scenarios. Are there any questions before we wrap up for today? Thank you for your attention, and I'll see you next time as we continue our journey through Oracle Database Administration at Ctech. Bye now.